Hey guys, welcome to AKB and this is Sushma. In this illustration, the distribution of return of security P and market portfolio, which is Q, is given below. The details has been given in the table, which containing the probability 0.3, 0.4 and 0.3. The return of P would be 30, 20 and 0, and the return of Q, which is the market return, it would be negative 10, 20 and 35. You are required to calculate the expected return of security P and the market portfolio Q. The covariance between the market portfolio and the security and the beta of the security. So going ahead with the solution statement showing computation of standard deviation. First of all, we need to compute the standard deviation. For the computation of standard deviation, I have the scenario. So we have probability 0.3, 0.4 and 0.3, and the return would be 30, 20 and 0. Therefore the expected return would be 9, 8 and 0. So when we multiply 30 into 0.3 will give you 9, and 20 into 0.4 will give you 8, and 0.3 into 0 will give you 0. For the return would be 12. Now x minus x bar, which would be x would be 30 minus, here you have 17 will give you 13, and 20 minus 70 will give you 3, and 0 minus 70 will give you negative 70. Now x minus x bar the whole square would be 30 into 30, which is 169, 3 into 3, which gives 9, and 17 into 17, which gives you 289. Now we have the way d2, and when we multiply the d2 with PA, which gives you variation, that is d2 into probability. So 169 into 0.3 will give you 15.7, and 9 into 0.4 will give you 3.6, and 289 into 3.3 will give you 86.7. So when you take the total, it would be 141. When we take the root of 141, it would be 11.87. So the standard deviation would be 11.87, and the return will be 17. Right, going further for the second one, that is the standard deviation statement for computation standard deviation of the market. As same, the probability will be 0.3, 0.4 and 0.3. Return would be negative 10, 20 and 35. When we multiply the return with the probability, we will get negative 3, 8 and 10.5. When we take the total, it would be 15.5. Now the computation of x minus x bar. So x minus x bar would be negative 25.5, 4 and 90.5. Now the d4, which would be the x minus x bar the whole square, which is 25.5 into 25.5, which is 650.25, and 4.5 into 4.5, which is 20.25, and 19.5 into 19.5, you 380. After computing the d2, that is x minus x bar the whole square, we need to multiply it with the probability. So the probability for the first case would be 0.3, therefore 0.3 into 650, and 0.4 into 20.25, and 0.3 multiplied by 380.25. So I'll get the total as 317. So when you take the root of 317, you'll get the standard deviation of 17.31, and the return would be 15.5. Now computation of covariance of the security and the market. So the covariance of the security and market would be, the main formula for the covariance would be standard d1 into d2 divided by standard deviation of P into standard deviation of Q. So it would be the covariance divided by standard deviation of Q. So for the computation of the covariance, I have made a table containing probability and return of the security, that is x minus x bar. So x minus x bar would be written over here as 13, 3 and 18, and 25, 4.5, 13, 3 and 18, which is x minus x bar, and over here it would be point 25.5 and point 4, 4.5 and 19.5, which is x minus x bar the whole square. So the x minus x bar the whole square has been taken, and when we multiply the both thing, it would come 33.15 and 13.5 and 33.15. So when you multiply the d1 into d2, which should be multiplied by the probability, and we will get 99.45, 5 and 99.45. So when you take the total, it would be negative 193.5. So the covariance would be negative 193.5 divided by 3.75 will give you, sorry, the covariance divided by standard deviation. Standard deviation of Q, which would be 317.25. You will get the covariance as negative 0.609. So guys, thanks for watching this video. I hope you are clear with this example. If you find this video helpful, please subscribe. Thank you.